Okay, number 12 on chapter 2. Which conditional statement can be used to write a true biconditional? So remember, for a biconditional, if P then Q has to be true, and then if Q then P has to be true. The converse and the conditional have to both be true. And that is when you're able to then write a true biconditional, which is where you say P if and only if Q. Okay, so we are looking for the one that's true forwards and backwards, which means that the others are going to fail in some way. So if a number is divisible by 4, then it's even. Well, that is true. But when you flip that and say if it's even and it's divisible by 4, that is going to be false. So what is a counterexample? Like the number 6. It's even, but it's not divisible by 4. Okay? If a ratio compares two quantities measured in different units, the ratio is a rate. That is true. If the ratio is a rate, then it compares two quantities measured in different units. That is true. So since both of those are true, I'm thinking it's going to be this one. I have 2 check marks there. We're thinking it's B, but let's just keep checking just to make sure. If two angles are supplementary, then they are adjacent. Well, that is true for if it's a linear pair. But if they're adjacent, then they're not necessarily supplementary. Okay. In fact, this first one is going to be false as well because they don't have to be adjacent to be supplementary. Okay, so that is going to be false. The conditional statement is true and is false, and the converse is false, and so that's going to be incorrect. And so if an angle is right, then it's not acute. That is true. But if it's not acute, the angle is right. That is going to be false. So what would be a good counterexample for that? An obtuse angle. Any obtuse angle. It's not acute, but it doesn't necessarily make it a right angle. Okay? All right, let's go to number 13. It says, for exercises 15 through 17, let P be, it is raining. Let Q be, it is thundering. And then let R be, we cannot swim. So what is if Q then P? Well, that's going to be if blue then yellow. So which one is if blue then yellow? If it is thundering, then it is raining. That is going to be my converse. That is going to be C. Okay. What is the converse of if P then Q? Well, that's going to be if Q then P. So again, it's going to be if it's thundering, then it's raining. So if it is thundering, then it is raining. That is going to be A. Okay, so I know you feel like we just did that. It's because we did. It's essentially the same problem, just a different way to ask it. If it is thundering in blue, then it is raining. Okay. All right, that's A. All right, 15. What is the contrapositive of R then Q? Well, if that's our conditional statement, what's the contrapositive? It's going to be if not Q, then not R. So let's do that in colors real quick. R was pink, so we're going to go if not pink, then... let Q be, it is thundering, so it's going to be if not blue, and then not R, so it's going to be not pink. So not blue, not pink. If it is not thundering, then we can swim. So if it is not thundering, then we can swim. That is going to be E. 15 is E. That is our contrapositive. And so what they did is they switched it. This became the blue, but they added the word not. This became the pink, but they changed it. So they dropped in the word not here. They took out the word cannot and made it we can swim. So they negated both of those. Okay. Which property of equality matches the conditional statement? And so our properties of equality, we did this on our Chapter 2 test, and we learned all of these different POEs and POCs. If it's an equal sign, it's a property of equality. If it's a congruent symbol, it is a property of congruence. So which one is this? It says if AB equals BC, so if AB is equal to BC, and BC is equal to CD, then you can transition out the middleman, and these outside two are equal to each other. So pink AB is equal to yellow CD. And so we know that that is going to be our transitive property of equality. All right, now transitive property is a certain form of substitution as well. So which property of equality matches the conditional statement if the measure of angle X equals the measure of angle Z? So let's do those in colors. Measure of X equals the measure of Z. Then you also can flip that around since that's an equal sign and say the measure of angle Z is equal to the measure of angle of X. Okay, so in my class, that was the Beyonce Singles Ladies Dance where we did X is 3 and 3 is X. So X equals 3 and 3 equals X. And so that is going to be our symmetric property, single ladies symmetric. Okay. All right, how would we solve 5x equals negative 10? So let's solve it. 5x is equal to negative 10. What do you need to do to both sides? You need to divide by 5. What property of equality is that? That is going to be the divpo. That's our divpo. Okay, division POE. All right, solve x minus 7 equals 10. What would you do to both sides? You would add 7 to both sides, and you get x equals 17. What did we do? We added to both sides. That is the addition property of equality. All right, which property of equality matches the conditional statement? If xy plus ab equals 15 and xy equals 5, then you can sub in, if xy is equal to 5, I can replace the I can replace the xy with a 5 instead. So that is going to be substitution. We're taking xy and we're plugging it into the equation. So they sub in. You have a different player come into the game for them. That is A. Okay, let's do a few more of these. Use the multiplication property of equality. If A, the measure of angle A, is equal to 15, then 4 times the measure of angle A is going to be equal to 15 times 4. Well, what is 15 times 4? That is going to be 60. So we had to multiply by 4 on both sides. All right, what can be concluded from the statement measure of angle 1 plus measure of angle 2 equals 180? What do we know that definition is? Well, 2 angles that add up to 180 are supplementary, and so that is going to be B. 2 angles that add up to 180 are supplementary. Okay, what property, theorem, or definition matches the conditional statement? If 1 and 2 add up to 90, then 1 and 2 are complementary. That would be our definition of complementary. Definition of complementary angles. Okay. What about if C is a right angle, then the measure of angle C equals 90? That is the definition of a right angle. If an angle is a right angle, it measures 90 degrees. Okay. Which property, theorem, definition, or postulate matches the conditional statement? If B is between A and C, then AB plus BC equals AC. So if I have A and C on the ends of segments, and I have B somewhere in between, then I know that this little piece in yellow plus this piece in pink adds up to the whole thing in blue. What is that called? That is called our segment addition postulate. So we have a segment addition postulate and we have an angle addition postulate. This one was talking about the segments. So segment addition postulate. Okay. All right, so now we have a proof, our first algebraic proof on here. And so if we're going to solve a problem, we have to start with a problem. So you're given the first step. So you fill this in, fill in the problem that we are given. That was given to us. And then what did they do to get from this step to this step? Well, they used the distributive property. You can tell they distributed. Distributive property. They distributed the 8 to the x and to the negative 1. Okay. Then they want you to subtract. They tell you what to do on this step. They say, hey, use the subtraction property of equality. So what are we subtracting? We're going to subtract, I'm going to subtract 5x from both sides. You could do many things here. You get to choose what you're going to do. But that gives me 3x minus 8 equals negative 35. And now they want you to add. So when you add to both sides, you would get 3x equals negative 35. And you're going to do plus 8. So that gives me negative 27. So that's the addition property of equality. And then we divpo it out. We divide by 3 on both sides. And so that is called the division property of equality. So did we solve what we wanted to? Was x equal to negative 9? Yes. How did we get there? We divided by 3 on both sides. Okay. And then the last one, we've got our proof on here. And so this is a segment addition proof because it's about segments. It's got different pieces, so I'm already thinking I'm going to be using the segment addition postulate. Okay. So what are we given? We are given that h to j, this whole thing, h all the way to j, is equal to 7x minus 27. So how do we know this part? This was given to us. Okay, and then it says in colors, we have the whole thing adds up to hj, and we have blue plus yellow adds up to pink. That is our segment addition postulate. Segment addition postulate. Okay, and then they just sub in those values. So what was blue? 3x minus 5. What was yellow? Yellow is x minus 1. And I set that equal to the whole thing, which is hj, which is 7x minus 27. So this whole thing is 7x minus 27 from here all the way to here. Okay, so what's it called when you plug things in? That is called substitution. Substitution. Okay? All right, so substitution POE. So now we are going to combine some like terms. They took the 3x and put it with the x. They put the -5 and put it with the -1. They're doing that on one side of the equation, so we're going to call that combine like terms. They didn't do it to both sides, so that's why we're not calling it addition. Okay, so now that we are here, they went from having a 3x on this side, a 4x on this side and a 7x on this side to just having a 3x. So how did they do that? They would have had to subtract the 4x from both sides. So minus 4x minus 4x. Since they did it to both sides, that is going to be called my subtraction POE. And then it looks like they took that 27 and they pushed it to the other side. How would they do that? They would add 27. So this is where I like to show my math as I go. It just shows what I'm doing each time. That is going to be my addition, POE. And then we would div-po it out. Y'all know I love the div-po. You divide by 3, you divide by 3. That would get you x equals 7. That is my division, property of equality. And then we didn't want to prove that 7 was equal to x. We wanted to prove that x was equal to 7. So what would allow me to flip that and interchange that? That is going to be my reflexive property of equality. Why equality instead of congruence? Because it's an equal sign. So we just flipped it around. Just shows that we can flip this around because of the reflexive property of equality. Oh, y'all, not reflexive. I'm so sorry. That's symmetric. Why did I just write that? Symmetric. Symmetric, symmetry, single ladies dance. Okay? The symmetric POE. Reflexive would be like if 7 is equal to 7, or angle x is equal to angle x. The measure of angle 1 is equal to the measure of angle 1. Okay, so that would be if it looked in the mirror and saw itself. Symmetric is where you can interchange those. All right. Thank y'all for your patience, and I am so proud of you. You made it through chapter 2.